So hi guys, welcome back to a new video. So myself yes Pranesh. So now I will talk about compare simple and double pendulum. So what is simple pendulum and double pendulum and they compare. So okay, let's come into video. So what is simple pendulum? A simple pendulum is another mechanical system that moves in oscillatory motion. It consists of a point mass suspended by means of light instantaneous straining of a length L from a fixed support as shown as diagram. So I will diagram in next slide. So I will see the diagram so you will clearly understand. Okay, the position acquires a vertical plane. So you know vertical plane and is driven by a gravitational force. The force which are acting on the mass are shown in a figure. So that's a force mass also. So the diagram. So you will see in next slide. Okay, the tangential component of a gravitational force one mg sin theta. So gravitational force component mg sin theta. The theta is always zero. Okay, the displacement, so the zero is zero, so restoring force acting tangent to occur. Okay, this is the diagram. So I will show, this is the diagram, the vertical motion. Okay, the mass. So this is the diagram, you will see. Sorry, this is the diagram, you see. Okay, a mass m suspended by a wire of a length L is simple pendulum and undergoes a simple harmonic motion for amplitude less than about 15 degree. The period of the simple pendulum T is equal to 2 pi root of Lg. So where T is equal to 2 pi Lg. So okay, super nice. Where L is the length of the string of and G is the acceleration due to the gravity. So nice. So since the period is independent of the mass, a pendulum of equal length at the same location oscillated with the equal periods. The analyzing between the simple pendulum is the mass springing system as soon as diagram. So I will check. I got the diagram. So the displacement, velocity, acceleration, kinetic energy, and potential energy are a various position of the pendulum. So nice. So next we will talk about what is double pendulum. So in physics and mathematics, in the area dynamically systems as a double pendulum. So if we know the dynamic system, we know C in physics or max books. Okay, so is pendulum with another pendulum attached to its end. So I will see a diagram so you will clearly understand. It's a simple physical system that estimate rich dynamic high behavior with a strong sensitivity to initial condition. The position of the double pendulum is governed by a set of coupled ordinary differential equation and charts. So see you diagrams you clearly understand. So this is the diagram. So the diagram explanation is below. So in a compound of the pendulum, the mass distribution. So you will see, you will read, you will understand. So there L1, L is the L by 12 m L square. So you will clearly understand. So okay, momentum from inertia I saw about the point. Um, okay, you will clearly understand. So we can move on to next slide. So okay, we will jump in to compare the simple and double pendulum. So okay, what introduction? We see introduction and line by line. You have so many comparison between simple and double pendulum. So okay, for first we will see in introduction. So we will write down the equation. So the motion we will see the equation. The simple and sorry for single pendulum, a single and a double pendulum. Okay, following Newton's equation and using Lagrange equation. So we see in the Lagrange equations. So figure one. So we see the above. This is a figure one. Sorry. Okay, a simple pendulum, simple plain pendulum left hand side. So we see left hand side is simple and right hand side is the double pendulum. Okay, free body diagram, the force on the east mass. So it is a free body diagram. You will see the clearly the free body diagram. So okay, we'll jump into next. So okay, not what is Newton's equation? Double pendulum consists of two mass m1 and m2. So you can see the double mass contains to m1 m2. Okay, we can see conquered by a rigidity weightless. rod of the length L1 and L2, subject to gravity force and the constituted by iness in the rod. To move in the plane, we choose a coordinate system with the originated at the top suspension point of x-axis, horizontal axis in the of plane of the motion, and the y-axis the pointing down the single plane pendulum, and similarly the case as a single particle hanging from the rigidity rod. Super was okay. So okay, we will constraints. So it's a constraint. So we will directly jump into the equation. So we starting in z is equal to 0 and r is equal to 1. Okay, double pendulum z1 is equal to 0, z2 is equal to 0. So compare r1 equal to l1. So r2 minus r1 equal to l2. So okay, we have many. So same simple pendulum case n1 and n3. Okay, r is equal to 1 sin theta comma cos theta comma 0. So okay, next r1 is equal to l1 sin theta 1 cos theta 1 comma 0. R2 is r1 plus l2 sin theta square cos theta square. So that's a square not a 2. Okay, wow. So it's theta 1 and theta 2, so 0. So we can express the velocity of the acceleration vectors in the terms of generalizing the coordination for a single pendulum. So okay, single pendulum coordinator r is equal to 1 sin theta comma cos theta. So r so this okay, v is equal to 1 theta. What is the dot is nothing but it is 0. Okay, so cos theta minus sin theta. So double dash cos theta minus sin theta minus 1 theta square sin theta comma cos theta. So we can know, so cos theta minus theta v. So it's equation v becomes the velocity is perpendicular to the position of the vector r, which is expressed on the constant r equal to 1 constant. We should recognize the tangential of the centripetal acceleration terms of propagation to the velocity and to indicate the industrial direction and respectively. So we can move to the slide. So we can the double pendulum is the same equation. So difference between double single and double pendulum is a no, nothing but 1 theta v cap. So it is a double gum. So l 1 theta 1 power v 1. So that's okay, you know, and the second particle in the first particle, that is the second particle r square is equal to a square equal to a1. So we can compare both. It is one of the is a constant and we can see in the force. Okay, f is equal to t minus r by modulation of r plus mg equal to minus t by l. So so you know modulus of t is equal to 0. Okay, okay, now f1. So we know equation. So you see this picture, you will clearly understand. And the equation of motion in a single pendulum. So this is equation of motion in a single pendulum. So there are the equations, so many equations, so many problems you can see and clearly understand. Okay, so wait, okay, the fourth equation, you know. So we know. So okay guys, thank you for the watching this wonderful video. So bye guys.